Good day, guys. This is March 30, 2026 tutorial session, and we're supposed to start by 5 p.m., but I pushed it to 5:30. So it's going to be a 1 hour tutorial session, and I would love to see more people join. I can see somebody has joined already. That's good. If you're on the live stream, you can just say hi to me in the comment section. You can let me know who you are, so that I just want to see more people joining. I'm going to share my screen very soon. I just want to see more people joining. Let me see. So I'm going to start real soon. So if you joined the live stream, you can just say hi to me in the chat box. Okay. So I'm going to share my whiteboard real soon. So if you see my whiteboard, you let me know. So I believe you'll be able to see my whiteboard now. I just want more people to join before I start teaching. March 30, 2026 tutorial session. Okay. Okay. So if there are more people, I would like to see more people. And this live stream is mainly for students from grade 7 to 9, but this live stream is open to anybody. If you're in grade 1, from grade 1 to a student from grade 1 to 12 are open to it. Even if you're in the higher institution and you have questions for me, you can come and join the live stream. But I don't want no advanced calculus questions because that's beyond my radar. Okay, let me talk about rounding up numbers that have decimals. Okay, rounding up to whole number, rounding up to 1 decimal place, rounding up to 2 decimal place, rounding up to 3 decimal place. Okay, so let me just put rounding up numbers. Rounding up numbers. Okay, so rounding up numbers. Okay, I don't start my live stream. I'll come. I carry my laptop good outside. Good evening, sir. You can come there. We'll go to that place. Okay, I'm going to share my screen back again. Okay. So I believe everyone should be able to see my screen now. Let me just go back to the whiteboard. Okay. So I'm just going to talk about rounding up numbers. I'm going to talk about rounding up numbers to whole numbers to like 2, 3 decimal places. So for example, let's say we have 594. Let's say 596. Okay. So if we want to round this up to a whole number, now the first number is 5 and the second number behind it is 9. So now numbers from 0 to 4, you add nothing to it. Okay. And then numbers from 5 to 9, you add 1 to the number that is written before it. And I'm talking about the number that is written behind the number you're considering to round up. So now in this case, we have 596. I said numbers from 5 to 9, you add plus 1 to the number in front of it. The one from 0 to 4, you add nothing to it. Okay. So in this case, where we have 596, so we want to round it to a whole number. So we want to take 9 and 6 to become 0. We have 9 at the back of 5. So we add plus 1 to 5. So that will become 6, right? And the 9 and 6 at the back of it turns to 0. So that becomes 600. So 596 rounding up to an whole number is 600. Okay. Let's try something a little bit different. Let's say we have 102. Okay. So we have 102 and we want to round it up to a whole number. So now you can see that there's 0 at the back of 1. And I said numbers from 0 to 4, you add nothing to the number in front of it. So if we want to round up to the nearest whole number, round up to the nearest whole number, that would be this 2 will turn to 0. So because it's 0, we are not going to add anything to 1. So that will be 100. So rounding 102 to a whole number is 100. Okay. For example, let's say we have 54. Okay. So if we want to round 54 to a whole number, we have 4 at the back of 5. It's from 0 to 4, you add nothing to it, to the number in front of it, right? So in this case, if we want to round up 54 to a whole number, that will be 50. So now I want to talk about rounding up numbers to decimal places. Now I want to give numbers that has decimals. Okay. So we're talking about rounding up numbers to, let's say, 2 decimal places. So the first one we have is 51.2684. Okay. So whenever we're talking about decimals, that is the numbers at the back of the point. Okay. It always has 51 point something something recurring numbers, right? So in this case, we have 2684 behind the dot, behind the point. So we have 51.2684, right? So the first two numbers at the back of the point is 2 and 6. So now we are going to be considering 6 now. Then we have 8 directly behind of 6, directly behind 6. So because it's 8 fall in the range of 4 to 9, we are going to add 1 to 6. Okay. So in this case, if we want to round it up to two decimal places, that will be 51.27. So that'll be the answer for that one. So now let's do 106.92. Now I want to round this to two decimal places. So we have 106.92. So that means we have just two numbers at the back of the point. So because we don't have any numbers behind 2, it's still going to be 106.92. Okay. So now I want to do 0.78415. So we have 0.78415. And we are rounding up to two decimal places. So 8 is the number we're considering because that's the second number behind the point. And then we have 4, 1, and 5. 4 is the closest to 8, right? And 4 falls in the range of 0 to 4. So we're going to add nothing to 8. So when we round this to two decimal places, that will be equals to 0.78. Okay. Now let's do something that has a big number in front of the point. Let's say we have 1.0519. Okay. We have 1.04519. Even though we have 9, no, but 9 is not the closest to 5, right? So 1 is when we are looking at these two decimal places, 1 is the closest to 5. Okay. So that will be equals to 1.05. So that's rounding to two decimal places. So now if we want to round 1.0519 to whole number, now let's talk about rounding this to whole number. So we're going to be talking about the number in front of the dot, in front of the point. Okay. So we have it as we have 1. 1 is the only number in front of the point. So in this case, we round to whole number. We have 1.0519. So that will be 1. So now let's say we have 0.764. And I want to round this to an whole number. 0.764. So 7 is the closest number to 0 before the point. So we're going to add 1 to 0. So approximately the whole number is 1. So if anybody have any question, you can put it in the chat box. So, but that's mainly what rounding up numbers is. Rounding numbers to different decimal places, rounding to whole numbers. So let me just talk about rounding to one decimal place, and then I'll move on to a new topic. So let's say we have 1.7142, and we want to round this up to one decimal place. Okay. So in this case, that will be 7 is the first number at the back of the point, and then we have 1 behind it. So 1 cannot we're not going to add a number to it, so that will be equals to 1.7. So let me just take one more example, and then we'll move on to something different. So we have 4.251. Okay. 4.251. So that will be 4.25 to one decimal place. that will be equals 4.3. Sorry, just give me a minute. Let me quickly give you, I'm coming. Uncle, let's come, let me give you. All right, guys. So I'm just going to do one more example before we move on to the next one. So let's say we have 10.48. Okay. So if we want to round this to one decimal place, we have 10.48. So we have 8 behind 4. So we add 1 to 4 because 4 is the first number at the back of the point. So that will be 10.5. So now we are going to talk about solving quadratic equation by factorization method. So let's talk about solving quadratic equations by factorization method. For example, let's say we have s squared plus 5x plus 6. Okay. So let's say we have s squared plus 5x plus 6. So now we know that quadratic equation is written as ax squared plus bx plus c. Okay. So when using factorization method, we are looking for two things. Now we are going to write the product of two numbers and the sum. And then we're going to look for two factors that when we multiply those two numbers, we'll get c. We'll get AC. And then when we sum it up, we get bx. So now the product is a times c. Ax squared times c. And the sum is the one in the middle, which is bx. That is from quadratic equation ax squared plus bx plus c. And then we're going to look for two factors that when we multiply together, we give us ax squared c. And when we add those two factors together, we give us bx. So in this case, we have s squared plus 5x plus 6. So we are doing the product. X squared times 6 is 6x squared. And then the sum is the one in the middle, which is plus 5x. Okay. And then we're looking for two factors that when we sum it up, we give us 6x squared. When we multiply together, we give us 6x squared. And when we sum it up, we give us 5x. So now so if we do 2 times 3, we give us 6. Okay. And 2 plus 3 will give us 5. So in this case, now we'll say that the factors will be 2x and 3x. Because if we do 2x times 3x, will give us 6x squared. And 2x plus 3x will give us 5x. So in this case, we're going to put these two factors in the middle term where bx is. So that we're now we write x squared plus 5x plus 6 as s squared plus 2x plus 3x plus 6. Okay. So now we are going to group it now. S squared plus 2x go one side, 3x plus 6 will go to the other side. So in this case, we have x squared. X is common between x squared and 2x, so we are going to use x to divide through. X squared divided by x will give us x, plus 2x divided by x will give us plus 2. And then we have 3x plus 6. 3 can divide 3x, 3 can divide 6. Okay, so in this case, we are going to use 3 to divide both sides. So that will be 3x divided by 3 will give us x, plus 6 divided by 3 will give us 2. Okay, so in this case, now we're going to write it out as x plus 3 and x plus 2. Okay, so that will be x plus 3 is equals to 0, or x plus 2 is equals to 0. So x is equals to minus 3, or x is equals to minus 2. And also you will notice that when we divided it, you notice that one of the factors appeared twice. So when you see that one of the factors appeared twice and the other factors appeared once, then you know that you are doing the right thing. So let's do something a little bit different from this. So the next one we have s squared plus 3x. S squared plus 4x plus 3. Okay, so we have x squared plus 4x plus 3. I'm coming. So now the product will be s squared times 3, which will be 3x squared. And then the sum is the one in the middle, which is 4x. So now we are looking for two factors that when we multiply together, we get 3x squared. And when we sum those two factors together, we should get 4x. So now let's find factors of 3. Okay, so 1 times 3 will give us 3. Now 2 cannot go in 3 because we have a remainder. And then 3 times 1 is still 3. So the only factors for 3 now is 1 and 3. So now when we add 1 plus 3, we get 4. So the factors now will be x and 3x. X times 3x will give us 3x squared. X plus 3x will give us 4x. So now in this case, we write it as x squared plus x plus 3x plus 3. So now when we use x to divide x squared and x, we have x plus 1. And then plus 3 divide x plus 1, 2. So now you can see that we've gotten x plus 1 twice. So that will be x plus 3 equals to 0, or x plus 1 equals to 0. So that will be x is equals to minus 3, or x is equals to minus 1. Okay. So now let's do something. Let me do another one. So we have s squared minus 7x. Let me see the one I did previously. So let's do s squared minus 7x minus 10. Let's try that one. So we have x squared times minus 10. So the product will be minus 10x squared, right? And then the sum is the one in the middle, which is minus 7x. So the factors we have will be, we need to look for two numbers, and when we multiply together, we get minus 10. So the 2 times 5 will give us 10. Minus 2 times minus 5 will give us plus 10. Okay. So you know what? I'm just going to tweak this equation a little bit. So I'll make it x squared minus 7x plus 10. so that we can get what we actually want to achieve. So the product is 10x squared, and the sum is minus 7x. So when we do minus 2 times minus 5, we get plus 10. When we do minus 2 plus minus 5, we get minus 7. Okay, so that will be minus 2. The factors now will be minus 2x and minus 5x. So now that will be s squared minus 2x minus 5x plus 10. So now when we use x to divide s squared and minus 12 after we grouped it, so s squared divided by x is x, minus 2x divided by x is minus 2. And then we use minus 5 to divide minus 5x and plus 10. So minus 5x divided by minus 5 is x. 10 divided by minus 5 is minus 2. So now it will be x minus 5 equals to 0, or x minus 2 equals to 0. So that will be x equals to 5, or s equals to 2. So now another one, I want to explain quadratic equation now by completing the square method. But what I want to do first is that I want to prove the quadratic formula by the there's a formula that we use, which is x equals to minus b plus or minus root b squared minus 4ac over 2a. So I want to prove this formula using completing the square method. So generally we know that quadratic equation is ax squared plus bx plus c equals 0. So now I want to prove this formula using completing the square. So now what I will do is that ax squared plus bx, and then I will take c to the other side. So when I take c to the other side, it becomes minus c, right? In the next 27 minutes. Yes, 20. So now we have ax squared plus bx equals minus c. So now whenever we are doing completing the square method, we are going to find half of the middle term, square it, and then the same half of the middle term, square it and add it to the right hand side of the equal sign. So now in this case, it will be ax squared plus bx plus b over 2 all squared is equals minus c plus b over 2 all squared. So this will be ax squared plus bx plus b over 2 all squared is equals to minus c plus b squared over 4. So now one thing you need to know that whenever we are doing computing the square method is that the one that contains square, we pick it and then group it together. So this one, it will be ax squared plus b over 2 all squared. So this will be equals to, sorry, I don't know what's going on with my pen. Okay. So this will be equals 4. Now we're going to make it like 4 the LCM, right? So 4 divided by 1 is 4. 4 times minus c is minus 4c, plus 4 divided by 4 is 1. 1 times b squared is plus b squared. Okay. So now in this case, I want us to divide through by a. So you know what? Let's ignore what I did earlier. I want us to first divide through by a before we make it a little bit more complicated. So let's divide through by a. So when we divide through by a, ax squared divided by a is x squared, plus bx over a is equals minus c over a. So now, like I said, we'll take half of the middle term and then square it. So that'll be x squared plus bx over a plus b over 2a all squared is equals to minus c over a plus b over 2a all squared. So now the ones that are squared, now we're going to group it together. So that'll be x plus b over 2a, everything all squared, equals minus c over a plus b times b is b squared. 2a squared is 4a squared. So now, because we have square on each side, what the best thing to do is for us to square root both sides. So let's square root both sides. And that'll be x plus b over 2a all squared. Now we should have the square root on top, is equals to the square root of minus c over a plus b squared over 4a squared. So this square will cancel the square root. So now we have x plus b over 2a is equals to. So now in this case, what I would preferably do is make 4a squared the LCM in this square root here. So 4a squared divided by a is 4a. 4a times minus c is minus 4ac plus 4a squared divided by 4a squared is 1. 1 times b squared is b squared. So now if we square root this, we have s plus b over 2a. That will be root minus 4ac plus b squared. The square root of 4a squared is 2a. So now let's bring this one to the other side of the equal sign. So that will be s is equals minus b over 2a plus or minus minus 4ac plus b squared over 2a. So I can rewrite this. I can write b squared before minus 4ac. So that will be s is equals to minus b over 2a plus or minus b squared minus 4ac over 2a. So now, because both have the same denominator, we can just group it together. That will be s equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is how we prove the formula through completing the square. So now the last question I did was s squared minus 7x plus 10. So we're going to solve this with completing the square method. S squared minus 7x plus 10. So let's do it out like this. S squared minus 7x equals to minus 10. So we're going to find half of the middle term. The middle term here is minus 7x. And then we'll square it. So that'll be s squared minus 7x minus into 7 over 2 all squared equals minus 10 plus 7 over 2 all squared. So in this case, if we group this together, that'll be x minus 7 over 2 all squared equals minus 10. 7 times 7 is 49. 2 times 2 is 4. So we have s minus 7 over 2 all squared equals, the LCM here will be 4. 4 divided by 1 is 4. 4 times minus 10 is minus 40. Plus 4 divided by 4 is 1. 1 times 49 is 49. So we have x minus 7 over 2 all squared. 49 minus 40 is 9. So that's 9 over 4. So now, since we have square x minus 7 over 2 all squared equals 9 over 4, to be able to get rid of this square, we will square root both sides. So when we square root both sides, the x minus 7 over 2 all squared, this square root will cancel it. So that will be the square root of 9 over 4. And the square root of 9 is 3. The square root of 4 is 2. So that will be x minus 7 over 2 is equals 3 over 2. So that will be x. And now, because it comes from the square root, there will be plus or minus in front of it. So that will be s equals 7 over 2 plus or minus 3 over 2. So that will be s equals 7 over 2 plus 3 over 2, or 7 over 2 minus 3 over 2. So that will be 7 plus 3 divided by 2, and 7 minus 3 divided by 2. So that will be x equals 10 over 2 or 4 over 2. So that will be 5 or 2, which is the same thing that we got when we use the factorization method. I'm also going to do the same thing with s squared plus 4x plus 3. S squared plus 4x plus 3. So we take this 3 to the other side, it becomes negative 3. So that will be x squared plus 4x is equals to minus 3. Okay. So the middle term here is 4x. So we're going to find half of 4x, add it to the left hand side, add it to the right hand side. So that'll be x squared plus 4x plus 4 over 2 squared equals minus 3 plus 4 over 2 all squared. So that'll be s squared plus 4s. 4 divided by 2 is 2. So that will be plus 2 squared all squared equals minus 3 plus 2 squared. So x squared plus 4x plus 2s equals minus 2 times 2 is 4. So that's minus 3 plus 4. So that we have x plus 2 all squared is equals to plus 1. So now let's square root both sides. So we square root both sides. So when we square root both sides, so that will be x plus 2 is equals plus or minus 1. So that will be s equals minus 2 plus or minus 1. So that will be s is equals minus 2 plus 1 or minus 2 minus 1. So minus 2 plus 1 is equals to minus 1. And minus 2 minus 1 is minus 3. So that will be s equals minus 1 or minus 3. And if we go back to look at the first question I did, you see that we got the same thing. So now let's try s squared plus 5x plus 6. S squared plus 5s plus 6. So in this case, the product, no, we're not using product, we're not using factorization method. So now let's take 6 to the other side. So that'll be s squared plus 5x equals minus 6. So that will be x squared plus 5x plus 5 over 2 all squared equals minus 6 plus 5 over 2 all squared. So that will be x plus 5 over 2 all squared is equals 5 times 5 is 25, 2 times 2 is 4. So we have x plus 5 over 2 all squared. So the LCM here will be 4. 4 divided by 1 is 4. 4 times minus 6 is minus 24. Plus 4 divided by 4 is 1. 1 times 25 is 25. So we have x plus 5 over 2 all squared is equals to 1 over 4. So now let's square root both sides. So that will be x plus 5 over 2 is equals to the square root of 1 over 4. So the square root of 1 over 4 will be 1 over 2. So that will be s plus 5 over 2 equals 1 over 2. So that will be s is equals 1 over 2 minus, so s, sorry. So s equals minus 5 over 2 plus or minus 1 over 2. So that will be s is equals to minus 5 over 2 plus 1 over 2 or minus 5 over 2 minus 1 over 2. So that will be s is equals minus 4 over 2 or minus 6 over 2. So it will be x equals minus 2 or minus 3. So that will be it for that question. So I want to talk about the kinematic equations. So in this case, I want to prove the 4 kinematic equation. And I dropped a video on kinematics in 2 dimension. It's on YouTube. I released it this afternoon. So I'm going to be proving this kinematic equation, all 4 equations. And then the way I'm going to be The way I'm going to be using the parameters is going to be quite different from what you see in your physics textbook. So this will be derivation. Yeah, I can see somebody has joined on the chat box. You can just say hi to me in the chat box. I appreciate it. So derivations of kinematic equations. So in this case, A will represent acceleration, V will represent the final velocity, U will represent the initial velocity, T will be time, and S will be displacement. So we know that the formula for acceleration is final velocity minus initial velocity divided by time. So that's A equals V minus U over T. So in this case, now I want to derive the first kinematic equation. So what we can do now is we can cross multiply. So A we have it as AT equals V minus U. Now we can make V subject to formula. So that will be V is equals to AT and then bring U to the other side plus U. So now if you want to rewrite it in a way that will be V equals to U plus AT. So that's equation 1. That's the first kinematic equation. And we use this when we are talking about kinematics in one dimension. Also, we know that the average velocity is the addition of the final velocity and the initial velocity divided by 2. That's the meaning of average. You divide by the number of what you are talking about, number of things you are talking about. So it's average velocity is equals to final velocity plus initial velocity divided by 2. And we know that the formula for velocity is displacement over time. Speed is distance over time. Velocity is displacement over time. And the difference is that velocity is a vector quantity and speed is a scalar quantity. So vector quantity is a quantity that has magnitude and direction. Scalar quantity has no direction but it has magnitude, like time, like temperature. No, those are scalar quantities. So now in this case, we want to place side by side the average velocity and the formula for velocity. So the average velocity is V plus U over 2, which will now be equals to displacement over time. And I use S to represent displacement, so that will be S over T. Okay. So now we're going to cross multiply and then use S as the subject of the formula. So that will be V plus U times T equals to 2S. So now let's use T to open it. Sorry. Since we're making S subject of formula, that's easy. So that'll be S equals V plus U times T divided by 2. Okay. So that'll be S equals V plus U over 2 times T. So this is the second kinematic equation. So now for us to get the third one, the first one we got was V is equals U plus AT. So we're going to impute V equals U plus AT into this equation 2. Impute V equals to U plus AT into equation 2. So that will be S is equals to U plus AT plus U over 2 times T. So it will be S, U plus U is 2U plus AT all over 2 times T. So let's use T to open this bracket. So that will be S equals 2UT plus AT squared all over 2. So let's use this 2 to divide it individually. That will be S is equals 2UT divided by 2 plus AT squared divided by 2. So these two will cross out each other. So S is equals to UT plus 1 over 2 AT squared. So this is equation 3. So now from equation 2, sorry, I don't know what's, let me clean this place. So now from equation 2, which is S equals V plus U over 2 times T. Now we can make the T subject of formula and impute it into equation 1. So if we do it that way, that will be S equals V plus U over 2 times T. So now let's cross multiply. 2S is equals to V plus U over T. So we want to make the T subject of the formula now. So that will be T is equals to 2S all over V plus U. So now we are going to impute V, which is the first equation. Impute V equals U plus AT into what we have above. So that will be T is equals to 2S all over U plus AT plus U. So that will be T is equals to 2S. U plus U is 2U plus AT. Oh no, that's not the way I wanted to do it. So it will be V equals to U plus A into 2S all over V plus U. It will be V equals to U plus, let's use A to multiply through, 2AS over V plus U. So now we have U over 1 plus 2AS over V plus U. So V plus U will be the LCM. So V plus U divided by 1 is V plus U. V plus U now into U plus V plus U divided by V plus U is 1. 1 times 2AS is 2AS. So we can use this U to open this and multiply it further. So V times U can be, we can write as UV plus U times U is U squared plus 2AS over V plus U. So in this case, we can cross multiply. So it will be V into V plus U is equals to UV plus U squared plus 2AS. So V times V is V squared plus V times U is UV is equals to UV plus U squared plus 2AS. So now this UV, let's bring this UV to the same side. Let's collect the like terms and bring everything and group it to each other. So that'll be V squared plus UV minus UV is equals to U squared plus 2AS. UV minus UV is 0, so they'll cancel out each other. So we have it as V squared now equals U squared plus 2AS. So this is the fourth and the last kinematic equation. So So let me just do one example, and then that will be the end of today's session. So let's say that a ball is thrown. No. A ball at rest is thrown with a velocity of 5 meters per second, and it accelerates in the air at 2 meters per second squared for 30 seconds. Find so let's find the distance traveled, or find the displacement. Let's say find the distance traveled. So now in this case, we said the ball is at rest. So that means the initial velocity, which is u, is 0. It's thrown with a velocity of 5 meters per second. The final velocity v is 5. It accelerates in the air at 2 meters per second squared. A is 2 meters per second squared. And the t is 30 seconds. So we know that 60 seconds make 1 minute. So in this case, for us to convert this to minutes, that will be 60 divided by 30. 30 divided by 60. So that will be 0.5 minutes. 0.5 minutes. So in this case, the best formula I would like to use is S is equals to UT plus 1 over 2 AT squared. So you use the formula according to the parameters you are given. So S is the distance, that's what we're looking for. Initial velocity is 0. Time is 0.5 plus 1 over 2. The acceleration here is 2. And then the time is 0.5. T squared is 0.5 squared. 0 times 0.5 is 0 plus 2 divided by 2 is 1. So that will be plus 0.5 squared. 0.5 squared, I believe, should be 0.25. So S is equals to 0.25 meters. And then we can still use this one. We can still use V squared is equals to U squared plus 2AS. So the V squared, the final velocity is 5, right? So V5 squared is equals to 0 squared plus 2 times 2 times S. So 25 is equals to 2 times 2 is 4. So that's 4S. So S is equals to 25 divided by 4. 25 divided by 4 will probably be 6.1 something. So that will be all for today's session. So, and I hope you all learn one or two things. And for those who have not learned any of the topics I did, I hope you were able to learn, and I hope you're able to refresh your brain. So that will be the end of today's session. Also, go check out my video. I uploaded a video today. That's some kinematics in 2 dimension. That one will be particular for the physics students in grade 11 and grade 12. And I hope you like. If you have not subscribed, subscribe to the channel. Thank you and peace out.